standard form of an equation with one variable. It's ax plus b equals 0, where a and b are real numbers. And they can be 0. So it could just be like 5x equals 0, or, well, if a is 0, b also has to be 0 for this to be true, right? 0 equals 0, that's the only way it would work. Okay, so a and b have to be real numbers, x is our variable, and in order to solve the equation, we have to undo what's been done. So anything that's happening to x, we undo it. So our first step here is we're going to rearrange where x is alone and numbers on the other side. So step 1 is going to be to add or subtract the constant from both sides. So in this case, we're going to subtract 3. And then step 2 is going to be to multiply or divide the coefficient. Okay, in this case, multiplication is happening, so we're going to divide. Get that x equals 7. Okay. Sometimes they're a little bit more complicated. As you can tell, example 2 has more steps than example 3. When that happens, we want to look at what's going on in the equation. Yeah, we've got the parentheses, so we have to distribute first. So we distribute that 2, and we get 2x minus 8 minus 5x equals negative 5. Now I only want one x term on this side, so I need to collect my like terms next. And I'm going to put on either side, because we have a negative 8 on this side, we have a negative 5 on that side, and those are like terms, but we can't cross that equal yet. We have to work on one side and work on the other and get each side simplified down as much as possible before we start moving from side to side. So I'm going to combine those two. Okay, so I get negative 3x minus 8 equals negative 5. Then I'm going to add or subtract. We're negative, so I'm going to add. And last, multiply or divide. So divide by negative 3. Can't tell without the 3. So x is going to equal negative 1. Between an equation and an expression, because equations cannot be solved, expressions cannot be solved. Okay, and you don't want to make that mistake to where you're trying to solve something that's not solvable. Okay. There is no equal sign in the expression. So we can only simplify it. An equation you solve, it has an equal sign, and then we have to simplify. So we simplify each side individually, and then we solve it. Okay, so we have an expression here on the left, no equal sign. We have an equation on the right, has an equal. Simplifiable only, solvable. So Step one for both of these is going to be to distribute. You're going to distribute that 3, and you're going to distribute this negative. Be really sure to do that. That's another mistake that gets seen a lot. Okay. Once I've distributed I'm going to collect like terms. 3x and negative 5x are alike. So I have 3x and negative 5x gives me a negative 2x. And negative 21 and positive 11 are alike. And so I get a negative 10. This is as far as I can go with this one. Now if I come over here to the equation, I'm doing the same first 2 steps. I'm distributing. I'm going to collect like terms, but I'm going to do it on each side of the equal separately. Okay, the right side of the equation only had 1 term, so there's nothing to collect. Then I'm going to add or subtract. This is only for the equation. Negative 10, so I'm going to add. Let's do the opposite of what's there. Then my final step is going to be the multiply or divide. We need all of our variables on one side. Now, there are actually 2 ways to approach this. So instead of actually writing out the steps, I'm going to show you both methods. I think that'll be more useful. So hold on 1 second. Okay, write this over here. Okay, so you have the traditional method, which is to add or subtract to move things from one side to the other. So I can subtract this 8x from both sides. So I have 5x minus 8x to get that negative 3x. And these two will cancel each other out. Okay. The other way that you can do it is if the adding and subtracting to both sides is a little confusing, you can actually just pick things up and move them from one side of the equal to another. So I can pick this 8x up and I can move it over here. If you do that, you have to change the sign. Okay, and think about when a really big, like football player, let's say, gets traded from one team to the other. A lot of times, sometimes they get to keep their same number. You guys have heard that, right? Yeah, they keep the same number, but they're not in the same color jersey. They have a different jersey, so same number but different jersey. So same number but different sign if you switch teams. So instead of being a positive 8x, if I move it over, it's now a negative 8x. So you can do that. You can just pick things up and put them on the other side if that's where you want them. You just have to change the sign. Okay. Either way, you still end up here. Then we can add 12 to both sides. And then divide by -3. And get x equals -12. Or you can use the same technique. You can pick this -12 up and you can move it over here. Except now it's positive. And you get the same answer. So it's just two different ways to approach the problem, and they're both correct. It's just a matter of which way kind of makes the most sense to you, and then use that one. Okay. When you have distribution, you always have to distribute first. That never changes. That negative in front of that 3 needs to stay with the 3. It's like it's car keys. It can't leave home without them. So you distribute in the negative as well. So -3x minus 6. That's another big error. I see what happens. People will distribute in the 3 but leave the negative behind, which makes this last number the wrong sign. So be really careful of that. Then we collect like terms. So I have 2x minus 23 is equal to -3x plus 7. At this point, we can use either method again. So I can either add 3x to both sides, or I can pick it up and move it. If I pick it up and move it, I changed its sign. I get the same spot. Add 23 to both sides. 5x equals 30. Divide by 5. And you get that x equals 6. So I'll show you both methods. I'll show you with the fractions and without. So over here will be with, and over here will be without. Okay. With the fractions, we need to combine them into one because they both have x's in there, so we need a common denominator in order to work with them. So common denominator will be 5 and 2 is going to be 10. So I'm going to multiply this by 5 and this by 5. And I'm going to multiply that by 2 and that by 2. To get myself a 15x over 10 is equal to a 16x over 10 minus 4. Now I'm going to move this 16x over 10 over here, so I'm going to subtract it from both sides, or you can pick it up and move it. (15x minus 16x gives me negative x. Okay. This is negative x divided by 10 equals -4 at this point. My fraction has become a division. So to clear this, I'm going to multiply both sides by 10. Those will cancel. And I get negative x is equal to negative 40. But I don't want to know what negative x is. I want to know what positive x is. So I just change both signs. So that's how you deal with it with fractions in there. But I know that a lot of people have aversions to fraction. Raise your hand if you have an aversion to fractions. You don't like them. Okay, be honest. It doesn't offend me. I'm not a fraction. So let's get rid of them. You want to see how to get rid of them first? Try it over here, maybe. Actually, if you hold on. Okay, so we can get rid of the fractions. You still need a common denominator, but instead of adjusting this to give these common denominators so I can combine them, I'm going to use my common denominator to get rid of the fractions. And what I'm going to do is I'm going to multiply this whole thing by the common denominator, which is 10. And what that does I'm going to multiply every single individual item by 10. And here's how that gets rid of the fraction. 2 goes into 10 5 times. Now that 2 is gone. 5 goes into 10 2 times. That 5 is gone. And now I multiply here and here. And I now have 15x is equal to 16x minus 40. Which got rid of the fractions, which makes it a friendlier problem for a lot of people. So if you can take the common denominator, you multiply every single thing by the common denominator, and your denominator cancels out. It goes away. Once you're here, you solve this the way you would any other equation that didn't have fractions in it. Subtract 16x from both sides to get rid of it. Negative x equals negative 40. So x equals 40. Okay, so this one has fractions with your variables and fractions without your variables. This is just all fractions, and so we want to get rid of them, right? So we're going to clear them. What is my common denominator? I have a 2, a 6, a 4, and a 12. 12. So I'm going to multiply this entire thing by 12. And what that does is multiply every single item in the equation by that number. 12 goes into 12 one time. 6 goes into 12 two times. 2 goes into 12 6 times. And 4 goes into 12 3 times. So I'm dividing. After I divide, I then multiply times my numerator. So 1 times y is just y. 2 times 1 is 2. 6 times y is 6y. And 3 times 1 is 3. This equation has the same value as the equation with the fractions in it. And we'll get the same answer for y. It's just that you now no longer have to deal with the fractions. So I'm going to subtract 6y from both sides. 1 minus 6 is 5, negative 5, sorry. And then I'm going to subtract 2 from both sides. Then I'm going to divide them out. So I got y equals 1, and I'm just going to show you that it still works. I'm going to plug that in and check it. Okay, so I plugged in the 1 for the y's. I'm going to give all these a common denominator. 1 plus 2 is 3. 6 minus 3 is 3. So even though I took away the fractions in order to solve the problem, I still got the correct answer. And so if fractions make you uncomfortable, which for a lot of people they do, you can clear them out. And then you don't have to work with them, aside from the initial clearing. So a ratio just compares two quantities. Can be written 3 different ways: as a fraction, as a sentence, or with a colon. So I could do a ratio. Let's see. There's 1, 2, 3, 4, 5, 6, 7. Okay, there's 8 girls and 10 boys in here right now. So my ratio I could write as 8 to 10, which then would have to be reduced. Or I could write it 8 to 10, or I could write it 8 to 10. When I reduced it, I created a proportion. These two ratios are equivalent. 8 girls to 10 boys is the same thing as 4 girls to 5 boys. It's just reduced, but it's the same ratio. So when you have proportions with variables in them, we use cross products to solve it. And to solve the cross product, or to use a cross product, you're cross multiplying. So I multiply 7 and x. I make an x. And I multiply 63 and 5. And then each of these goes on either side of the equal. So x times 7 goes on one side, 5 times 63 goes on the other, like that. And then once I've done that, I can solve this. So x times 7 is 7x, 63 times 5 is 315. I divide both sides by 7. And x is equal to 45. If I have an expression, I can still use cross products. I'm going to do x minus 10 times 30. So the whole thing times 30. And then this 20 times x. So So 30 times x minus 10, that's this cross, is equal to 20 times x, that's that cross. Then I distribute. I'm going to subtract 30x from both sides because I only have x's over here, so I'm going to move that way. And I get negative 300 is equal to negative 10x. Divided by 10. Can't see that, but that's what I'm doing. X is Now you can check your work and plug these back in and see if the two fractions are equal. If I plug in a 45 here, I get 63 over 45 is equal to 7/5. Both of those dividing by 9 does reduce to make an equal fraction. If I plug in a 30 here, I get 20 over 20 is equal to 30 over 30. They both reduce to 1, so those are also equal fractions. Set up the proportion. You want to make sure that you set it up correctly, okay? So if you have, okay, sum unit 1 over sum unit 2. So let's say this is miles and that's hours, miles per hour, okay? When you go over here to set up your other proportion, this has to be unit 1 and this has to be unit 2. So if it's miles over hours, it has to be miles over hours. You can't have miles over hours and then hours over miles. So the two different fractions have to be in the same position as far as what you're talking about, okay? And that's really important because if you flip it, nowhere near the right answer. Okay, so we have property tax on a house is assessed at $480,000 is $5,760. So this is the house money, house price, and this is the tax. Okay. Determine the property tax on a house with a value of $600,000, house money, assuming the same tax rate. And so we are trying to find out that tax. Okay, so we know the two house values and we know the tax on one house. We want to find the tax on the other, but we don't know the rate.
So you put the X within the passive.
Yeah. So you can call this X, you can call it T, you can call it whatever letter you want. Now, when we set this up, I happen to like to put the small number on top and the larger number on the bottom because I think it looks nicer, but it doesn't actually matter as long as you do the same on both fractions. So if you put tax over house, you have to do tax over house. If you do house over tax, you do that for both. So it doesn't matter which. I'm going to do tax over house. I don't know what that one is. 600,000. Now, trick, if you have a fraction that has zeros at the ends of the numbers, you can cancel out corresponding zeros. So I'm going to be multiplying by 576 instead of 5,760. And I'm going to be multiplying by 48,000 instead of 480,000. Makes it a little easier, smaller numbers. You don't have to, it's the same value. I'm going to cross multiply. And I didn't happen to memorize my 600,000, so I'm going to quickly do this. Then I divide both sides by 48,000. So the $600,000 house would have $7,200 in tax. This is with equations. You can have one solution, no solutions, or you can have infinite solutions. and this is with linear equations. Okay, so straight lines. Okay, and this example we're going to solve, we distribute the 2, and I get 2x plus 6 is equal to 2x plus 4. And I'm going to subtract 2x from both sides, and those are going to cancel, and so are those. And I'm going to get a statement that is false. Oh, you're right, 8. Thank you. I'm still going to get a false statement. Thanks for catching that. So 6 equals 8. Not on this planet. If you get a false statement, there are no solutions. Okay. So any statement that's false. 1 equals 975. Negative 3 equals positive 3. These are not the case. Oh, sleep. Okay, so anytime you get a false statement, your answer is that there are no answers. I'm going to distribute that 6. I'm going to collect like terms. And once I get here, I could actually stop because they match, right? But let's say I didn't notice that they matched, and I subtract 4x from both sides, and I get that 6 equals 6. Well, as a matter of fact, yes, it does. If you get a true statement, you have infinitely many solutions. You can write infinitely many solutions. You can put a big R like that for all real numbers. Oh, actually, let me go back. When you get no solutions, you can put this symbol, which means the empty set, which means there are no solutions. So you don't have to write no solutions. You can just make that. This is not a 0. This is a 0. That's not a 0. And this double R thing means all real numbers. So every solution. Okay. What we're going to do is I'm going to go ahead